Hey, welcome to another edition of Toolbox Tuesday. Today we want to talk about a thing that's very, very crucial to the HVAC industry, the furnace tune-up or clean and check as some may call it. Depending on what area of the country you live in, the way you do a cooling check or heating check at your particular company may vary. For example, up north, where there's a lot going on the heating side, their heating season is very, very long. Cracked heat exchangers are a big issue. However, in some of the warmer climates, they're not as prevalent as they are in some of the colder climates. So what that means is when we're doing our checks, that the technicians in those regions of the country may have to actually pull the blower motor or use a device to look inside, a scope or something like that, to look inside and actually see the heat exchanger. Well, in an attic that's 120 plus degrees, pulling the blower motor might not be on your list of favorite things to do on that day. However, we want to make sure that we do have some device when we're checking in heating to check for cracked the heat exchanger, because the byproducts of that can be very, very dangerous to a homeowner. And we want to make sure that we're protecting not only the homeowners, but also ourselves while we're working on it. So we have a huge responsibility as HVAC technicians, especially doing just a preventative maintenance heating check to ensure that the equipment is working properly and that we are protecting our homeowner. So let's kind of dive into some of the things that you need to do when you're doing an HVAC heating tune-up. The first thing is make sure that you're the one who turns off the power, right? You don't want to leave that to someone else. Make sure that you turn off the power, and when you get to your unit, you're going to use your voltmeter to check at your incoming source of power over here at your junction box to make sure that you don't have any power floating through there. You might want to grab a meter that's got a non-contact voltage setting on there. That way you can kind of wave it in there and check within to see if you have any voltage, or actually take your leads and touch to the place where you think the last known source of power is to make sure things are free and clear. One of the other things that you want to do is you want to make sure that your gas is turned off. Now you can either do it inside here, or you can actually go all the way out and turn it off before the gas enters the house. Whatever your company says is the practice that they want to keep, make sure you stay in line with that. Now, there's a bunch of components and parts and things within our system that we need to check. But remember, this was a heating tune-up or a heating clean and check. So vacuuming out the cabinet, making sure that everything is clean, that there's no dirt and debris. You want it to not to look better. You want it to look better than it did when you got there, right? So if the homeowner comes upstairs or goes in the attic or the closet and opens the unit, they should see at least a shiny piece of equipment that is clean. So we want to make sure we get all the cobwebs or anything that may have collected inside of our unit out of the way. The next thing that we want to do is we want to go ahead and check our filters. Right? So we want to check our filters and make sure our filters are being cleaned. This is also an amazing opportunity to have a conversation with the homeowner. Ask them how often do they change their filter. You can ask about the amount of traffic flow or if they have any pets. These kinds of conversations can lead to conversations about indoor air quality products. Now, when it comes to indoor air quality products, a lot of our homeowners are just uninformed and not educated about those products. Now, if we're, as technicians, if we take the time to have the conversation about that, it can be a revenue generating opportunity for the company. It can be a health benefit for the customer, and it can then turn into a revenue generating opportunity for the technician as well. So make sure you have those conversations about the filter. We want to check our filter and change our filter and make sure that we had a nice clean filter in there. And then we transition into the conversation about whether or not our homeowner is on a preventative maintenance program. If they're on a preventative maintenance program, then great. Then that comes standard as part of the service depending on what company you work for. Or if they're not, we can recommend, hey, Mr. and Mrs. Homeowner, you don't necessarily have to take care of this yourself. We can upgrade your filter to one that will last you 6 to 7 to 8 months, even a year, depending on traffic in the house. And then we can change your filters for you, and you never have to worry about them. Who wouldn't want that service? So checking your filters is very, very important, and also make sure you have conversation with the homeowner regarding the benefits of indoor air quality products and your filter. Now, As we go through here, we kind of check some different things out. We're going to check amp draws on our motors. We have an inducer motor and a blower motor in here. We want to check an amp draw on the motor. The reason why we need to check that amp draw on the motor is we need to make sure that our motors are operating within tolerance. If that amperage tends to get too high, we could then compromise the integrity of those motor windings, and our motor, the windings inside of there may burn up, lock up, seize up, and then our motor is not working anymore, and then there's a problem overall. So we want to check to make sure our motor is operating within manufacturer specs. There's a couple of other components that we need to check as well. One of them is a hot surface igniter. So depending on which type of hot surface igniter you have, there's going to be a list of tolerances or resistance that each one can have. Some of them are low as 11, 12, 13 ohms of resistance. Some of them are as high as 150 ohms of resistance. You have to know the type, and then you also have to know, based on that type, what the manufacturer says is the tolerable range of resistance for that particular igniter. One note that you need to take care of is when you test the igniter, it is best to test that very early on. Once that igniter has heated up and fired a couple of times, then those resistances could change. So that's something that you want to check right away and get it at its earliest and coldest stage if you can. Now, the other particular component that you want to check in conjunction with that is our good friend, the flame sensor, right? So our flame sensor's job is to kind of prove that we have a flame and send a message to the board saying that it's okay to initiate the next stage in the sequence of operation. Now, there's been a couple of videos out and we've seen it all. There's a lot of different things out there that you can clean and check your flame sensor with, but you want to make sure that it clean and it tests where it needs to test. And a lot of times manufacturers will say that that's above 1, which says we have a healthy flame sensor. So those numbers could range anywhere from 2.4 to 4.2 and anywhere in between. But the thing is, when you check it, make sure you know what the tolerance is for it per the piece of equipment that you're working on, and make sure you're above that number. Now, there's one other thing that you need to be aware of as it relates to flame sensors. You could be on an LP system, which is going to have a higher BTU content as far as the flame is concerned. Well, natural gas, we know, is going to put out 1,050 BTUs, whereas propane, you're going to be at around 2,400 BTUs. So it's a hotter burning fuel, if you will. Because of that, because of the temperature on a propane system, you could cause damage or see damage to where you've actually eaten away at the flame sensor. I've only seen it once, but I have seen it happen and I've heard people talk about it. Now, once we move on from the flame sensor, we want to check our capacitor and make sure that our capacitor is operating within manufacturer specs as well. If it doesn't, then we might have a ECM motor, and we might need to use a ECM motor tester in order to test that. All of these devices can be bought at your local supply stores, and they're great things for a technician to have in his tool bag. Now, that takes care of a big majority of the furnace, but one of the things that we have to remember is every furnace that we run into isn't necessarily going to be the latest, greatest piece of equipment. It could have a little age on it. So with that, you may run into a pilot situation where you need to relight the pilot or relight the burners if need be. You also may have a motor that's actually belt driven. So at that point in time, you may need to check out the belt and make sure you've got the right amount of tension on your belt so that your blower motor continues to operate properly. The other thing that you want to check is your input and output gas pressure. You're going to use your manometer to check your gas pressure and make sure that your gas pressure is okay. We may even use our manometer to check static pressure throughout our system, as well as making sure that all of our wire connections are nice, all of our safeties are working properly, especially the pressure switch, making sure those hoses and tubes are cleaned, so on and so forth. And so if we have a 90% furnace, we might want to check condensate drains and different things like that as it relates to furnaces that are 90% efficient and above. All of these types of things we need to check on our heating tune-ups and heating cleaning checks. Now, that by far doesn't cover everything that you necessarily have to check, but it does cover a big majority of the basics. Each company out there is going to have maybe some different things that are specific to the region or specific to their customer base that they've just added to their deal. Whatever that is, just make sure that you do a very, very thorough job and understand the importance of a heating tune-up or a heating cleaning check as it relates to the preventative maintenance and the safety and comfort of the people that we serve, our customers. So once you've done all of that, you've got everything nice and cleaned up, make sure you don't leave your meter on top of the furnace and then head out, because you'll be looking for it on the next job. Clean your area up, make sure that you get ready to put your doors and things like that back on. Give it, after you've completed your heating check, you kind of want to give everything a once over and kind of take a look at everything and make sure your area is nice and clean. And lastly, make sure you leave your system running. One of the things that I've seen done and heard people talk about that I think is just kind of spot on is they always take their temperature differences and check their temperature rises at the very, very end of their check. Why is that? Because in order to get that properly, the system needs to be running. And so that way you can ensure that when you left the house or the last thing that you did, that system was operational and you didn't forget to turn the gas back on, or turn the power back on, or whatever the case may be. Those are just some cool practices, some things that you can do while you're conducting your heating, cooling, or your heating tune-ups and your heating cleaning checks for the future. We thank you for tuning in to another edition of Toolbox Tuesday. Look forward to hearing from you soon, and we'll speak to you next time. Hey, we absolutely love our HVAC community. We want you to continue to tune in. We want you to continue to leave us your comments. Make sure you click below to subscribe. We definitely want to hear from you, and we'll see you next time.